The first rule is the easiest. If you just have a constant, so like y equals 5 or y equals 2, and you're trying to find the derivative of a constant is just 0, okay? So the rule is if f of x is equal to c, and c is a constant, then f prime x, remember f prime x is the way we talk about a derivative, that equals 0. Yes. So if f of x equals c, which is a constant, then f prime x is equal to 0. The derivative of a constant is always 0. So I'm just going to write that down under explanation. Derivative of a constant equals 0. So for example, if f of x is equal to 4, then f prime x is equal to 0. Pretty simple. Now it's going to make sense when we start talking about real life applications, why it is that the derivative of a constant is 0, or why the derivative of a squared term becomes a linear function, or why the derivative of a cubed term becomes a squared term. Okay. All of that's going to make sense when we start analyzing the graphs of these first and second derivatives and the original function. Now, before I move on, there's something I do want to mention, and that is what we're doing, and this is called differentiation. I mentioned it to you before, but this is just a process of finding our derivative. It's the process of finding a derivative. That's also called, and your IB question bank likes to interchange, it's also called the gradient of a function. Gradient is slope, right? Now the notation that we use I mentioned this before, but in case we forgot, we have either f prime x or dy over dx, which is the derivative of y with respect to x. The derivative of y. Oh, zoom out. Derivative of y with respect to x. And let's just call this the gradient function, not the gradient of the function. The gradient function. All right. The power rule is the one that is really a game changer in terms of making finding a derivative pretty easy. Basically, it says this, and let me zoom in. If f of x is equal to, let's just say, x to some power, then the derivative or the gradient f prime x is going to be equal to, now here's what you do. You take that power, you bring it to the front, and then it's raised to a new power. That new power is whatever the original power was minus 1. So n x to the n minus 1.
May I go upstairs real quick to the math studies classroom because I'm borrowing a charger from him.
Yeah, quickly. Yep. So here's the explanation. The power of that function is multiplied by the coefficient. So power is multiplied by the coefficient. So you take the power, you bring it down in front, and you multiply it by the coefficient that's already there, whether it's 1 or 2 or 3 or whatever. And the new power is the old power minus 1, or n minus 1. So in other words, let's take an example. Let's take an example that we worked with yesterday, which was f of x is equal to 1 over x squared. Let's say we want to find the derivative. Well, with the power rule, I want to get, if I'm dealing with a fraction, get it to the numerator from the denominator. So this becomes f of x is equal to x to the negative 2. And then you just follow the rule. So that means bring the power out front. So you bring your power out front. And then you take that exponent minus 1, which gives you negative 3. So that's the derivative. So that avoids all that work that we did over the past 2 days with doing f of x plus h minus f of x over h, and then finding the limit as h approaches 0. We can just do the power rule now and simply move the power to the front and subtract the current power from 1. Do we have any questions? So the constant multiple rule just says that if we have a constant in front of our function, you're going to take that same constant and multiply it by the derivative. It's not going to change. So to give an example here of the rule, if, let's just say in general, if f of x equals c times u of x, and c's are constant, it's a constant, then the derivative f prime x is equal to c times u prime of x. So in other words, if there is a constant times a function, if there is a constant being multiplied by or times a function, that constant will be multiplied by the derivative as well. Great. Okay, forgot to charge my pencil. there's a constant times a function, that constant will also be multiplied by the derivative. As an example, let's say we have, oh no, okay, let's say we have, if f of x is equal to 2x, then f prime x is going to be the constant times that derivative. Well, the derivative of x to the first, you bring 1 out to the front and you subtract 1 from 1, which is 0, right? So that's 2 times x to the 0, which is just 1. So that equals 2. Questions? Basically, derivatives go down a power. Right, so you got x to the first, that'll go to 0. X to the second, that'll go to x to the first. X to the third, that'll go x to the second, because the power rule says n minus 1 with that power. All right, the sum and difference. So it says this. Let's say if you have a sum, you have a function that's the sum of two expressions. So let's say it's u of x plus or minus v of x. Then the derivative is just the derivative of those two expressions, added or subtracted. U prime x plus or minus v prime x. So in words, the derivative of the sum or difference of two functions is the sum or difference of both derivatives of those functions. So the derivative of the sum slash difference of two functions is the sum or difference of both derivatives. The derivative of the sum slash difference of two functions is the sum slash difference of both derivatives. So here's an example. Let's say we have a function, f of x is equal to 3x squared plus 2x minus 1. We want to find the gradient of that function. You're just finding the derivative of each piece that's being added or subtracted. So the derivative of the first one, you can use your power rule. Bring the power out front, subtract the power by 1. That's 3x squared, so you bring the power out front. So f prime x, 2 times 3 is 6. You subtract the current power by 1, so instead of being an x squared, that's an x. The second one, The power out front is 1 times 2, which is 2. And that's x to the first, so you subtract 1 from that power, which is x to the 0. So you have 6x plus 2. And then minus, well, the derivative of a constant is always 0. So that's the derivative of that function. So you're just adding or subtracting all of those derivatives at once. Questions? So the last one. All right, so let's move on to finding that instantaneous rate of change for something like y equals 7x minus the square root of x plus 3 over x squared. I would suggest, John, that if you have a fraction or if you have a radical, make them powers so that you can use the power rule. So go ahead and give that a try. And then I taught you how to put this into your calculator yesterday. Give it a try, find your derivative, plug in 1 by hand, and verify that you did it correctly on your calculator. So they say to find a tangent, you want to find the derivative, find m by substituting the x value into f prime x, find y. This will make more intuitive sense as we go. So let's take a look at what they're giving us as far as the equation is concerned. They say y equals x cubed minus 2x squared plus 4 at x equals -1. They want the equation of the tangent line. So to find the equation of the tangent, I need to find the derivative, because that's what the derivative helps me get, is the equation of the tangent. So I'm going to find that derivative. So I'm going to say dy over dx, remember that's another way to write the derivative, is equal to, and I'm going to use my power rule, okay? 3 goes out front, 3x squared. The 2 goes out front, and you subtract 1 from the power, 4x, and then the derivative of a constant is 0. So that's my derivative. And now it says find m by substituting the value into f prime x. Substituting the x value into f prime x. So in other words, find that instantaneous rate of change. So I'm going to plug in into f prime x the x value, which is -1. Well, -1 squared times 3 is 3, plus 4 is equal to 7. In other words, what I just found is, let me scroll up, that instantaneous rate of change. So this is step 1. This is step 2. So our m is equal to 7. I found the derivative. The derivative helped me find the instantaneous rate of change, which is that slope of the tangent line. Now step 3 says find y by substituting the value of x into the original function. So I found my derivative, which helped me find the slope of the tangent line. Now I'm going to find the y value from my original function. So my original function is f of x is equal to x cubed minus 2x squared plus 4. Okay, you're going to substitute your y value into the original function.
The screen.
Yep. So you're going to take f of -1, because that's the x value that they give you. Cube it. -1 minus 2 plus 4. It's going to be -3 plus 4, which is equal to 1. So I'm finding the equation of my tangent line. Let's review. Step 1, find the slope of that tangent line, which I do by finding the derivative. The derivative helps me find the gradient or slope of that tangent line by finding the instantaneous rate of change. This is the same thing, calling it the gradient. When you find the instantaneous rate of change, that is the slope of the tangent line, so you need to find the y value of the point where your tangent line crosses. It crosses, we know, at an x value of -1. We find the y value, which is 1. So the point that the tangent line crosses through is -1, 1, and the slope of that tangent line is 7. So now you can do y equals mx plus b. So y equals mx plus b. The y value is 1. The slope is 7. The x value is -1. The b value I need to find. So this is just algebra 1 skills. So 1 is equal to -7 plus b. 8 is equal to b. Therefore, y is equal to 7x plus 8. That is the equation of your tangent line. Okay? Questions? So this product rule is in addition to the other 4 rules that we learned. We have 6 rules that we're going to learn. Maybe 7. Okay, so the product rule says if f of x is a product of 2 expressions, then here's the derivative. And I'm just going to write it out, and then I'm going to tell you how I remembered it in high school. Ooh, let me make this a little bit more legible. Zoom in. The product rule says if we've got the product of 2 expressions,
This is so
the derivative is the first times the derivative of the second plus the second times the derivative of the first. If you can remember that, you remember the rule. The product rule is first times the derivative of the second plus second times the derivative of the first. And I'll show you an example. And I'm going to write this down because this is how I remembered it. First times the derivative of the second, plus second times the derivative of the first. First times the derivative of the second plus second times the derivative of the first. That's when we are taking the product of 2 expressions and we want to find the derivative of that product. Wait until we divide 2 of them. That's another one. This whole first unit is about these rules. Practicing these rules, getting fluid with these rules, finding the derivatives of things, expressions, functions first. The second unit is all about applying this to kinematics and things in real life and analyzing graphs. All right, so turn the page and let's take a look. We're gonna skip the quotient rule, save it for tomorrow. So number 3 and number 4 we're gonna do together. You've got a product. Let me zoom out. You've got a product of x plus 3, that quantity, and the other quantity 2x squared minus 7. We want to find the derivative, so we're going to do the product rule. First times the derivative of the second. So that means dy over dx is equal to first is x plus 3, times the derivative of the second. The second is 2x squared minus 7, right? So the derivative of that is 4x. Because bring the 2 down to the front, and let me scoot this where you can see it. So I brought that. So first times the derivative of the second, 2 times 2 is 4x, and then that's just 0, right? First times the derivative of the second plus second times the derivative of the first. Which is 2x squared minus 7 times the derivative of the first, which is just 1. Because x to the first, bring it out front, subtract a power. And then you multiply and simplify. And that's your derivative. First times the derivative of the second, second plus second times the derivative of the first. So, but remember, the derivative of a constant is 0. So first times the derivative of the second plus second times the derivative of the first. And then you multiply things out, and you get 4x squared plus 12x plus 2x squared minus 7, which is 6x squared plus 12x minus 7. That is what dy over dx is equal to. The function that will give you the slope of the tangent line, or the instantaneous rate of change. Questions? That was number 3. Let's end with number 4. First times the derivative of the second. First is square root of x plus 2. Derivative of the second. Okay, so since I'm dealing with a fraction over here, maybe I want to rewrite it to 3x to the negative 2 plus 5. So the derivative of the second, is negative 6x. So oops, forgot my x. So first times the derivative of the second plus second times the derivative of the first. Well, again, square root of x is x to the 1/2. The derivative of x to the 1/2 is just 1/2 x to the negative 1/2, right? Akil, are you with me? You remember, as I'm giving a lecture, you need to make sure you pay your fullest attention. Don't be looking at videos right now because that really messes up the learning process. You can do so afterwards. Questions so far? Because at this point, it's just about simplifying. Okay. So you take negative 6x to the first times x to the 1/2 plus negative 6x times 2. So it's, again, it's algebra. Do you have strong algebra skills here? So when you add those two numbers, because you know when you multiply exponents of the same base, you add the powers. We're going to be doing that here. So you have negative 6x to the negative 5/2. Do that right? Yep. This is x. Oh, I forgot here. For number 4, we've got the x plus 2 first times the derivative of the second. The second, it should be negative 3 on the power, right? Because I forgot to subtract. Because originally, this is 3x to the negative 2. So it had to be negative 2 times 3 and then x to the negative 3 because this was x to the negative 2. You always have to subtract 1 from the power. So that should be a negative 3, right? Okay, that's why it's negative 6x to the negative 5/2. Okay, so I'm just multiplying straight through here. Negative 6x to the negative 5/2 minus 12x to the negative 3 plus 3/2 x to the negative 5/2. And this is just algebra. This is nothing new. You have fractions in your variable, in your exponents. But I believe that by this point you can deal with that. If that means you have to rewrite stuff, and like for example, taking 3 over x squared and making it 3 times x to the negative 2 and then adding your fractions, then do that, but it's just an addition thing. And that is your derivative. Okay. We're going to save the quotient rule for next time. The homework that I'd assigned is not even over the product rule. I'll give you a worksheet on that. So do the book work because it's over the first 4 rules that we talked about. Do that tonight. And then tomorrow I'll give you a worksheet to work on in class over the product rule and the quotient rule. And we'll go over an IB question.
Do you send the 3 of us the PDF sheet?
Of the worksheet?
We're not here.
Oh, tomorrow. Yes, I haven't made it yet, but I will send it to you.